So my name is Kainton, the Tech Pro, and today we are going to continue with question 7 on our data science question and answer series. And this question is going to be explain the least squares method of linear regression. So before now, you already know you already understand the concept of linear regression, and now we are talking about a method used for linear regression called the least square method. So I'm going to right away explain it and then use some notations and diagrams to explain it clearly. Least squares is a method of solving regression problems by minimizing the sum of squares distances between each observation and the fitted regression line. So I'm simply going to start by taking an example. So let's say we have the observation plotted here. This is y and this is x. Okay. Permit me to use a different color. So we have the observations plotted in this place. Let's say we have different observation here. Okay. So now I fit a linear regression line. This time I'll use blue. I try to fit a regression line through this data. Okay, though not perfectly okay. So we have the intercepts. All right. So now if we fit this line through this data, then we are going to have equation of this line will be a function of x, which is going to be beta 0 plus beta 1 x, which you already know in case of linear regression, right? However, the actual relationship between this, the x and y value should be y is a function of x. So given yi, permit me to use another color of pen. So given yi, to find yi, we simply use a function of xi. Now take note that this function of x and function of xi is not the same as this f hat of x given here. So ideally it should be the same, but since we are doing an estimation, we can't get it perfectly accurate. So there is going to be a difference between our function f hat of xi and f of xi. So that difference is what we are trying to control. This difference has to be minimum, because if this difference is minimum, then most likely our model will be close to the correct relationship between the two. So what we are going to do is, first we are going to give the names to these labels. So maybe I'm going to just use white. So assuming this is x1, this is x2, this is x3, this is x4, this is x5, this is x6, and this is x7, right? So for sure it's data point xy, yeah, coordinate xy, but just for simplicity, let's call it x. All right, so now what we are going to try to calculate is the distance from this data point, from the data point to our regression line. So we are going to be interested in this distance from here to here, because that is the error that we have. So we're going to be interested in this distance here. We are interested in this distance here. This as well, this distance here, this distance here, and we have this distance right here. So let's take, for instance, for x1, the distance is given by f of x1 minus f hat of x1, right? So this is the difference. So in other words, the difference is, I have to take another color as well. The difference is y1, not yi. Let me just erase this. So we have y1 minus f hat of x1. Okay. So which is the same thing as y1 minus beta 0 plus beta 1 x1. So for the second one, for x2, we have y2 minus beta 0 plus beta 2 x2. We now have y n for n number of items minus beta 0 plus beta n xn. Okay. All right. Now, in case of sum of squared, least squared method, we are trying to take the total sum of all of these, and then we are going to square them. If we did not square them, then it means that the negative will cancel out the positive, and maybe we'll have 0. But since we are going to square them, we ensure that we are capturing all the distances. So we will have an error. Let's call it E. I'm going to use red because that is error. We are going to have E error is equal to, now we are going to sum everything from I is equal to 1 to n. And we are going to say yi minus beta 0. So now I'm going to use a little braces plus beta I x I. Okay, so I'm going to square this. All right, so basically this quantity here is what we are trying to minimize. So this is the sum of squares, and then we are trying to minimize the sum of squares. So this is how the least square method works. We are trying to minimize the sum of square distances between the regression line and each of the data sets or each of the observations. So I'm actually going to stop here, and I would like to thank you for viewing, and also I'd like to remind you to subscribe to my channel if you have not done so already.